Modern digital production relies on a specific structural bottleneck. Every piece of AI generation is funneled into a few monolithic central servers. Subscription-based software companies manage their compute overhead by artificially metering your access, which restricts the total volume of your outputs. For high-volume execution, this architecture introduces latency. Every prompt requires a round-trip server request, slowing every step of the production pipeline. We can bypass the cloud intermediary using a sovereign, localized software architecture running directly on the host machine. This shift is enabled by the Bring Your Own Key, or BYOK, protocol. Notice the direct point-to-point connection on the right. The protocol routes data straight from your local environment to the Google Gemini API. Removing the third-party node drops recurring processing costs to zero. Decoupling the interface from centralized external servers shifts the application ownership and the processing power back to the local user. To demonstrate how this functions, we are going to chronologically construct an automated software pipeline natively on a desktop environment. The process begins with the input parameters. The system must ingest raw, unstructured URL data from any web page. From that single input, the system generates 19 distinct outputs across text, audio, and visual modalities, all within a single 45-second cycle. Traditional human-operated workflows require coordinating these outputs over thousands of hours per year. Our build will use localized first principles to reach this level of execution density. Our pipeline begins with the ingestion of a raw target URL text string. Raw web data contains significant noise, including tracking scripts, formatting tags, and excess HTML code. We introduce an initial filter node into the architecture, powered by the Cheerio cursing library. This node scrapes the target page and isolates the document object model, or DOM. It systematically strips away non-essential elements, discarding the layout code to leave only semantic data. The output emerging from the node is a compressed, pure text block. This sanitization process reduces the token weight of the payload. Isolating a stripped text payload preserves the context window and prevents API token waste during the LLM handshake. Before that payload can be transmitted, we must secure the connection. The application environment is a self-contained Electron desktop executable, requiring us to store the user's API key locally without exposing it to malicious scripts. We utilize the OS keychain protocol, secured with local CTR encryption. This protocol integrates directly with the native operating system's built-in credential manager. Standard SaaS applications pool thousands of user API keys in centralized cloud databases. By keeping the key local, we eliminate that third-party security liability. True sovereign architecture requires the API key to never leave the host operating system. With the payload sanitized and the key secured, the system initiates the API handshake, routing directly to Google Gemini. Traditional AI prompting relies on sequential, one-at-a-time user queries, which is inefficient for production. The pipeline routes the data into the central router, the orchestration matrix. This matrix structures a single prompt payload to force the LLM into parallel output generation. The matrix architecture dictates formatting rules for 19 distinct variables simultaneously. Forcing the LLM into this multi-section schema prevents it from losing focus or generating unrelated data. The system processes all 19 parallel pathways within a single context window. This parallel processing completes its entire cycle in roughly 45 seconds. A human team coordinating these same 19 outputs manually would take several hours to align the assets. Forcing an LLM into parallel multi-node processing via a single matrix payload is the engineering shift that replaces a human-operated production pipeline. Let's examine the data structures traveling down these 19 pathways. While some nodes generate metadata, like SEO tags, specialized nodes perform more complex tasks. These nodes convert the text payload into system-ready directives meant to trigger external AI models. The visual generation node formulates shot sequencing and aesthetic directives for Luma or runway models. The static image node constructs composition and lighting syntax for Midjourney thumbnails. The audio generation node structures persona, topic, and tone parameters for Notebook LM audio protocols. Prompt engineering at this machine-to-machine level is necessary to ensure high-fidelity outputs. The end user never has to write these complex prompts manually. Generating tuned prompts rather than basic copy transforms the application into an orchestration engine capable of directing entire external AI ecosystems. The final piece of this architecture is monitoring the cost of the API calls. We integrate a real-time telemetry node directly into the pipeline header. This node interfaces with the Gemini API to extract raw usage metadata after every execution. It calculates cost by mapping token consumption against the live API pricing index. Flat-rate SaaS subscriptions often obscure actual compute costs. Real-time telemetry provides total operational transparency. Live token telemetry transforms cloud processing into verifiable local economics. The user pays only for exact compute usage. Pulling back to a macro view, we can now view the fully constructed pipeline running seamlessly from end to end. The architectural sequence is complete: one raw URL ingestion, one DOM strip, and one secure local API handshake. This process delivers 19 production-ready multimodal outputs generated natively. This chart directly compares the two models. A localized BYOK architecture maintains a zero recurring API footprint, unlike costly cloud-dependent subscriptions. Coupling an Electron desktop interface with direct BYOK routing circumvents the subscription economies of modern software platforms. High-density automation is moving towards sovereign, decentralized execution environments fully controlled by the end user.